Scene opens with a close-up of a person looking at their smart speaker. User: Hey, what's the best route to the airport considering the afternoon traffic? And can you find a coffee shop on the way that has good reviews? The smart speaker's light ring glows and pulses as if thinking. Narrator: Ever wondered what happens in that split second between your question and the answer? It's not magic. It's the incredible power of neural networks, the digital brain behind the voice assistant you use every day. So how does this complex system turn your spoken words into a perfect, helpful response? Let's dive in and explore the hidden journey of your command. Visual shifts to an abstract digital space. A glowing, intricate web of interconnected nodes and pathways materializes. This is the neural network character. So, what exactly is a neural network? Imagine a brain but built from code instead of cells. It's a sophisticated system designed to recognize patterns, process information, and learn over time, much like we do. In this digital brain, each node is like a neuron, and the connections between them are synapses. When you speak to your assistant, information doesn't just follow a single path. It travels as pulses of light, zipping through this complex web, being analyzed and interpreted at lightning speed. This structure is what allows your device to understand not just words, but context, intent, and even nuance. The scene breaks down the process into 5 distinct visual stages. It all happens in 5 key steps, starting the moment you speak. First, there's the wake word, "bare." The user is shown speaking the wake word. Animated sound waves travel from their mouth towards the smart speaker. When you say, "Hey, assistant," the device is constantly listening for that specific audio pattern. This initial command acts as a key, unlocking the system and telling it to start paying attention to what comes next. Once activated, the second step begins: speech to text. The sound waves are shown entering the device and transforming into a string of digital text on screen. What's the best route? The neural network analyzes the unique frequencies and patterns of your voice, converting the analog sound waves into digital text. This process, known as automatic speech recognition, ASR, is incredibly complex, as the network must account for different accents, background noise, and speech speeds to transcribe your words with high accuracy. Next comes the most critical part: natural language understanding, or NLU. The digital text is now inside the neural network. The network glows brighter as it processes the sentence. Keywords like best route, airport, traffic, and coffee shop are highlighted. Here, the neural network doesn't just read the words, it comprehends them. It identifies your core intent, in this case needing directions and a recommendation. It breaks down the sentence, understands the relationship between airport and traffic, and recognizes the secondary request for a coffee shop. This is where the true intelligence of the system shines. With your intent understood, the network moves to action and response. The neural network is shown reaching out with lines of light into a vast, shimmering cloud, representing the internet and various databases. It pulls back specific data points: a map route, traffic data, and coffee shop ratings. It queries multiple sources simultaneously: maps for routes, traffic APIs for real-time conditions, and review platforms for coffee shops. It then synthesizes all this information to formulate the most relevant and helpful answer. Finally, the 5th step: text-to-speech. The synthesized text answer is shown transforming back into clean, smooth sound waves, which then travel out of the smart speaker. The network converts its formulated text response back into natural-sounding audio. It generates a voice that has an appropriate tone, cadence, and inflection, delivering the answer clearly and conversationally,